Hello, everybody, and welcome to another episode of the Thoughtworks Technology Podcast. My name is Ken Mugrage. I'm one of your regular hosts. We have an exciting episode today talking about experimentation that we're doing in the generative AI space. Co-hosting today with me is Neal Ford.
For the second podcast in a row, we've promised an exciting episode before we've actually said anything, so we'll see if we can make that come true. And I think it's absolutely going to come true today because we're talking about one of the favorite hot topics right now, which is generative AI and its uses.
And our first guest, Birgitta, would you like to introduce yourself?
Yeah, hi, I'm Birgitta Böckeler. I'm a distinguished engineer for Thoughtworks in Germany, and I'm currently a full-time subject matter expert at Thoughtworks for using generative AI on software teams and for creating software. So not putting AI into a piece of software, but using it to build the software.
And Chandru, you want to introduce yourself, please?
So I've been with Thoughtworks since 2009, and 10 out of those 15 years I've been with various retail accounts. So I'm starting to see myself as a specialist over there.
So for today's episode, we're going to talk about using generative AI for one facet of legacy modernization, which is one of the bigger use cases for it. Experimentation is really important overall because you really need to set a goal, or we can overload the term hypothesis or what have you, and run tests and understand, and kind of the scientific method, if you will. You try something, you pass or fail, you move on. And again, it's pass or fail. So you're trying to learn from the experiment. And we have as an industry and as Thoughtworks, we have a long history of this. I mean, you can go all the way back to continuous integration, and then it wasn't called CI at first, continuous delivery and microservices and data mesh and et cetera. It was trying different things, building on what works, killing what doesn't. Sometimes not as fast as we should, frankly. But it's that idea of trying things and seeing what will work and being, frankly, a little bit brave. So the one we're talking about today, I want to actually ask Birgitta to talk about a experiment that we're doing when you don't have access to all of the building blocks for a legacy application. So Birgitta, what are we talking about today?
Yeah, so I mean, like you said, legacy migration and legacy modernization is a very interesting use case for generative AI with a lot of potential. And we've done it and seen it in a lot of different areas already. And there's kind of like this workflow that is emerging that is always very, very similar, but then each step is done in different ways. So, you always, like when you have an application that you want to rebuild, right? Be it a COBOL module or like a 15-year-old monolith or 20-year-old monolith or something like that. And so you have certain data sources that you can use to find out what that application even does. So if you want to rebuild that functionality, right? You have the code, maybe you can look at the application itself in a test environment, in your production environment. You might have documentation, all of these different things. And so what we usually see is not, let's take generative AI, give it the old code and recreate immediately the new application. So this kind of A to Z, COBOL to Java is the furthest distance for that, I guess. But it's more like, how can we step by step do this? And in each of the steps, AI helps the human do the step, right? The first step being, let's create a description of what the functionality is today of the COBOL module or like whatever the application does. And then, take that description and also double check it with a subject matter expert, with users, like whoever is relevant in that domain, right? And then take that description and feed it into the forward engineering. So feed it into creating stories, creating new backend API design, stuff like that, right? And so what we want to talk about today is a case of this workflow. In terms of the data sources, you don't have access to the full code. So this might be because maybe you had a bad breakup with the vendor and they didn't leave the code behind. You only have the binary. Or it could also be because you do not want to access some of the code because it's so messy that you've experienced that confuses generative AI, right? So that's kind of like the premise or the setup of the experimentation that we did. And so we'll talk about that first, and then later Chandru will also chime in on what we experienced when we started doing that at an actual real case.
Yeah, we actually had even less data sources than what we anticipated. We thought we'd have a running application, a test environment where we can just see how things were. And, that core requirement was also missing.
But that's getting a little bit of ahead. So let's talk about this approach. I think it's particularly appealing for not using generative AI as a COBOL whisperer to translate all the messy COBOL code into, pristine Java code. Because a lot of times the reason the legacy migration is so difficult is because it has been layers and layers and layers of changes and updates and maintenance and by different teams. And, at some point it becomes incomprehensible even to generative AI. So looking at it purely from a behavioral standpoint, I think is a useful way of thinking about reverse engineering the existing behavior of an application. We're throwing around some terms before we got started. Let's talk about some of these. Is this reverse engineering? Is this a black box? So how black is the box are we talking about here? So let's do a little bit of clarification around the approach here.
Yeah, terminology, right? Yeah, so at the moment, I always call it a two-step process. And I say AI accelerated reverse engineering and then AI accelerated forward engineering, right? Where the reverse engineering only includes a description of the application, not actually building it. So the forensics kind of, right? So you do forensics on the existing application and the existing code to kind of recreate a good description of what it does. And because we can now use generative AI in the forward engineering, there's a new incentive for us to actually create this description in textual form in a lot of detail. Right? In the past, maybe we wouldn't even do it at that level of detail. We would still in the forward engineering maybe have stories as the placeholder for a conversation because we want to build a new fresh application, right? But now that we can use AI for the forward engineering, there is an incentive there to have very detailed descriptions, right? And it maybe even changes the equation of cost benefit when we think about parity, feature parity. So that's also one of the hypotheses, right? That with AI accelerated reverse and forward engineering, feature parity might become less of a sticking point.
Well, especially if you can actually build better behavior than, just replacing the old behavior that's already there. I know Ken has a question, but I'm curious about a little deeper investigation into exactly how do you investigate the behavior of the existing system? Is this through user interface or through inputs and outputs? Is it through change data capture? Is it, or all of those things plus other stuff?
Yeah. And there's some established techniques that we already have, right? So I see this over and over again that combining generative AI with techniques that we already have is where the magic happens, right? Not when you only use generative AI. And so in our first experimentation that we did, we actually used different techniques than we then used later at the actual client where Chandru was, right? So in that experimentation phase, first, we actually focused very much on kind of dynamic data capture, indeed. And so when we did this was a few months ago when the first MCP servers were just coming out that actually allow you to browse an application, to have your AI coding assistant or whatever AI tool you're using to control a browser and click through an application and actually find out what's on the page, right? So that was the first thing we tried. We used the Playwright MCP server, which is one of the MCP servers built by Microsoft. And it uses the Playwright end-to-end web testing framework under the hood. And then my AI, my coding assistant, for example, my agentic coding assistant can go and explore the application, right? So in this case, we used Odoo, which is an open source ERP system. And we used one of its components, the customer relationship management, and we asked AI, so we want to rebuild this functionality to create a new opportunity in the sales pipeline. Here's the page, the URL of the page where that's happening. Create a description of all the functionality. Try to find all the possible actions, all the possible click paths, describe all the elements on the screen that you see, describe any dynamic behavior you see. For example, there were things like when the user selects a value in this dropdown, then the application pre-fills all the other fields, which is kind of dynamic behavior that you cannot see just from a screenshot. And when you use something like Playwright MCP, AI actually gets access to the DOM structure. Multimodal large language models can actually also do this just based on visuals, right? They can just look at the screen and then say, click at coordinate X and Y, because they see a button there. But using something like Playwright MCP is a lot more effective because it gets access to the to the DOM, right? So it's faster and more reliable. So that was kind of the first step, this dynamic click, explore the application and create a description, and also create screenshots for us on the way. So we didn't have to take screenshots manually.
Actually, with a lot of prompt experiments, we were able to kind of get a very detailed specification. So Playwright, as soon as it's given access to a running website, it not only knows what are the visual elements that are present over there, but it can also, to an extent, discover and specify what happens on blur, what happens on focus, how the elements interact with each other. So if we had to do that manually, then that's going to, either result in some, things being missed, or take a really lot of time to put together that specification. I was particularly impressed with how quickly and easily Playwright can just browse through the pages, give us a specification of what user journey is happening, and this is a really valuable document for us when the time comes to do the forward engineering part. And one other thing worth mentioning is the documents that we create, right, can be iteratively enriched. So you start with an initial specification, and then you discover, okay, I can make Playwright do a different journey, give it a different prompt. And then AI is really good at merging two different specifications together, such that what's missing from one document can be enriched into the other document. Again, that's an activity, if I had to do manually, it would really be a painful process, like looking at two specifications, find out what's missing, and then creating a master document out of it is not something that we want to spend too much time there. So I found those aspects super useful when it comes to creating the specification. And Birgitta, I don't know if you wanted to mention it next, but the server, the exploration of the UI was not the only data source in Birgitta's experiment. I think she also used CDC. It's not really change data capture in the normal way of how people mean it. It's more like monitoring what is changing in the database as we browse through the application. So as the Playwright MCP server was helping us go through page after page, we could potentially use an MCP server to find out what are the changes happening behind the scenes in the database, like what inserts are happening, what updates are happening, and then provide that as context back to the AI. And our models are smart enough to understand what's happening and put that also in the specification. So that becomes an even more rich document for us later.
So do you have a feel, obviously one of the things that gets thrown around whenever you hear reverse engineering or black box or any of those terms, kind of touched on it a few minutes ago, is do you own the application or are you doing it on somebody else's app? And of course you wouldn't have access to the database. I wouldn't think. What was the quality difference when you did that? When you added that step of watching the data and seeing what changed in the back end, do you have a feel for how much better the discovery got, or was it? Did you do a checkpoint there at all?
I think it gave us a lot more confidence. Our intention was to recreate the application going forward, and the exploration, just using the front end, was very good at specifying the behavior of how the user journey should progress and how the user experience should be. But it was not very good at specifying how we have to build the application going forward. So having the insight coming from the database, and normally applications do a lot more, than talk to database. So as we add more and more data sources into our as we provide more and more context to our model coming from different data sources, then it gives us more and more confidence to accurately recreate the application when we do the forward engineering. I know Birgitta wanted to say something.
It was a lot more than increasing confidence, right? Because it was in this case, the only indicator we had of what was happening in the backend. So this was definitely not like a black box exploration. It was more like gray box, right? So the things that we allowed ourselves to access. I mean, in the experiment, we set those boundaries ourselves, but we allowed ourselves to access the front end, for example. That's kind of like not a black box anymore. We can see the rendered DOM, right? And we allowed ourselves to access the database schema. We allowed ourselves to do that, to create those database triggers, right? So the kind of like change data capture in concept, right? We didn't use like a specific change data capture product, but we created like a lightweight version ourselves with database triggers. And without that, we wouldn't know anything about what happens in the backend, right? So this is in this experiment, the only indication we had of what's happening in the backend. And like in a real world application, like it depends a bit on the type of application. Often in like digital products or enterprise business software, the data processing is the main step, right? So the what actually happens on the database query level is like the main thing that's happening, right? But there's often, of course, like more stuff happening under the hood. So, and you still have to, from the queries, infer a lot about and guess a lot about what logic is happening, right? So depending on how much of that logic there is in an application, you might have much more blind spots in one application than in another. And that's where the subject matter expert sanity check comes in, right? Where you then look at what you get from AI and see what's missing here. Like there's also things like calling other services or sending an email, right? Like calling up an SMTP service or something like that. So we didn't do that as part of the experiment, but that's of course also something that you have to keep in mind. So it's all about augmenting the humans that are creating this description, but it's not AI only creates the description and it has everything.
Yeah. So you just mentioned one or two other possible data sources, SMTP server. What are some others? Are you thinking about? I mean, you watch the network for API calls. What would give you the most complete picture?
Yeah. I mean, it might be, like I said, it might be calling other services in the landscape, right? In the client case that we'll get to in a few minutes, we ultimately discovered there might be some mainframe calls. Other things might create events on, on some kind of like enterprise service bus is maybe like a good example for like an old application like that where you want to replace. So we actually also, as part of this, one of our team members also explored network capture. So kind of to see, can we have this like clicking through the application and not just check what changed in the database, but also check what network requests happened. So we only did that for network requests between the client and the server, let's say. And we could actually like recreate like a Swagger API documentation of what the current backend API looked like. That gives us another indication. Maybe we don't want to rebuild exactly that API, but it gives us another indication, right? But it might also be interesting to do network capture between the backend and whatever else it's calling to. Like we didn't try that. I also, at the moment, don't have like a good idea of what that would look like or if it's even possible. Again, depends on the environment, but that could maybe be an additional data source.
So as this matured, could you see this, and I'm going to use a little bit of a dirty word here, like almost a lift and shift? I mean, is that?
This is a lift and shift, yeah.
Okay. Is that a pattern that you recommend for people? I mean, I know we're getting into the forward engineering now. Okay, I have an application. I rely on it. I don't have access to all the information about it. Should I lift and shift as a baseline?
I mean, let me maybe rephrase when I just said, yeah, lift and shift. What I meant is more what I mentioned before about the feature parity. So it's almost like lift and shift feature parity. But I think typically when people say lift and shift, I mean, maybe it depends on the context, but it was like when cloud started coming up, it was a lot of this, just take your load and lift it and shift it exactly like that to the cloud. And then maybe it's not optimized for cloud. And so you want to re-architect, right? So it is, I think, for use cases where you want feature parity type lift and shift, but you do not want technical lift and shift, right? Because this like multi-step workflow actually allows you to forward engineer like a modern stack that implements the same functionality.
I would call this not at all black box. I would call this a very light gray box kind of reverse engineering, because you have the user interface, you have what changes in the database. And for most legacy applications, I don't want to diminish that, but those are the trivial bits, because the really complicated part to recreate are all the layers and layers and layers of source code, all the business logic. Okay, yeah, the database changed from these fields to this field, but why? For this particular workflow. And that's going to be layers and layers and layers of changes and exceptions and those sorts of really, really messy, complicated things. And so I think one of the things, and I think Chandra is here to talk about this, you did to get even more confidence in this was actually take some of the source code that you had in binary form and decompile it to see if it's actually doing what you thought it did. Can you talk a little bit about that, please?
Yeah. So we had the same uncertainty that you talked about. So we kind of know that there could be a lot of hidden logic, let's say within the binaries. We really wanted to see if we can crack the DLL and find out a little bit more if there is any business logic within that. We know what's happening in the DB, but like you said, we don't know if the rows were how they were calculated, basically. So we don't know if some math happened. What if some 10 percentage or some threshold had to be respected? So all of those business logic, if it was happening within the let's say middle layer, we did not know if we can accurately find that and recreate it in our forward application.
To set the scene, like in this case, we did actually, so this was like a Windows stack, as Chandru said, there was a DLL, but we did have access to some of the front end code, so to some of the ASP code. So we saw some of the client side stuff happening, and we had the database schema, of course, and the stored procedures. But the actual black box, to an extent that we wanted to make more gray, was the DLL, right? That application server.
Yeah, I think what we tried to do is we know that it's 2005 legacy binary, and it was a Windows binary as well. So try to look for tools that can help us get insight into this binary. And one tool specifically stood out. So this tool was called as Ghidra, and it's an open source project from NSA. And I was particularly impressed about this tool because it was able to run on a Mac on an M1 processor and still give us the assembly that's sitting within the DLL that was originally built in an x86 processor for Windows. So it's a bit of, for some reason, I assumed that, okay, if this is a Windows binary, if it's a built long ago when .NET wasn't even a hot topic, so it's probably going to be tied to that ecosystem. It's not going to be easy to look into it. But Ghidra tool actually surpassed expectations and still gave us a good view of what's there within that assembly. So of course, it's free. So that's another point working towards it. It offered bulk decompilation. It was able to take all the binary and then convert it back to C code for us. The C code was not super readable. It was still pretty obfuscated, but it was something because a lot of other tools were not offering the bulk functionality. They were offering, let's decompile one function or a part of it, and then the full feature set was more of a commercial offering there. So for all those reasons, and also for because of the fact that it was like a very powerful editor, easy to learn, this was really helpful. So what we did there is we asked Ghidra to basically give us a C version of what's running within the Windows binary. So we got like 5,000 lines out of it, and the C code was also not very readable. So initially we were like, okay, did I just catch the tiger by the tail? How am I going to make sense of 5,000 lines of C code? And then started to use AI a little bit more to make sense of it. As soon as we started this experiment, we ran into all sorts of limits. The first limit was the file was too big; it could not be streamed to the AI. Then the next challenge was we split the file, but still AI was doing a lot of analysis. It was analyzing, it was going through the files, it was analyzing even more. But then we did not have any output because the analysis continued to take such a long time.
We should mention here that we were using Gemini Pro for this, right? So that was the AI tool of choice at this organization, and Gemini Pro has 1 million context window. right? So it even has like a really large window.
And then we ran into 429s. We ran into rate limiting after some time because at this point in time, we thought we'll split it into one function per file. And then we had I think 3,800 files, and we ran into 429 requests. And then we finally found out that, okay, we needed to break down this problem. And what we did next is uh, we created a Python program to make sure that we send file by file to our model and then ask it to translate it into pseudocode, each of those functions. And we also tried to classify, we also asked AI to classify it, whether it's a library function or if it's a function that's related to business logic. So this kind of filtering really helped us. I don't think it would have been possible before to classify a lot of these functions like this in bulk. But I think in this sense, at least AI did a pretty good job of telling us, okay, so this is a C++ standard library function. Okay, but this, on the other hand, is most likely business logic over there.
Just real quick on that classification, you said it was mostly accurate. Like, do you have a feel for how accurate it was, and what would be the consequence if it was inaccurate and you missed it?
I think one possible consequence is we run the risk of sometimes missing the business logic. So given the large amount of available resources for what constitutes a C++ library function that's already available in the internet, this information really helped AI to identify those footprints, or let me say the fingerprint of those functions, whether it matches with the standard library or not, in a good fashion.
Maybe before you continue, Chandra, with the decompilation process, like your question about the impact, Ken. So generally, like when working with generative AI, with coding, and I felt that especially in this process, like you're constantly doing risk assessment, right? You're constantly like thinking about what is the probability that Gen AI gets this wrong. That's based on like thinking about what information did I give it? How did it even come up with this? Did it have access to that information? Where is it coming from? And then the second one is, what's the impact of getting this wrong, right? So in this case, this was actually like a relatively straightforward application with a bunch of forms that the user fills out and then it lands in the database. So there was like, so you can kind of like, and we have access to the database queries and stuff like that, right? So that's another part about probability and impact. And so the process that Chandru is in the middle of describing right now, the decompilation, was for us another sanity check. Because at this point, we had already fed AI with screenshots, with the ASP code, with the database schema. And so we had gotten to a point where we had kind of inferred already what we thought was happening in the backend. Like kind of like based on the schema and what you see here in the form, what do you think is the SQL query? Because we didn't have access to a test environment, so we couldn't do data capture. So that's what we had at this point in time. And now what Chandru is talking us through right now was our next level of kind of like getting more confidence in the probability that we had it right.
So yeah, thanks for bringing that. I think that helps in validating how accurate our classification is also, because we have the information from before. We can compare and check if it falls in line with what we know already so far. So, I mean, after doing this classification, after filtering down a lot of functions that we obtained from the binary into a small set, we noticed that there are some inaccuracies, like we couldn't pinpoint a specific function that we were looking for. So it's a pretty important function that happens on submit of a particular functionality. So we really wanted to pinpoint and identify what's happening in that area. And that's when we noticed that with Ghidra, despite it being a very powerful tool, it can sometimes miss important information as it decompiles from assembly to C. In our case, we were looking for a specific query, and this query was not available in the C code, but it was available in the assembly code. So we decided, okay, AI is doing a pretty good job with analyzing the C, but let's switch to assembly itself. Assembly code is super hard for us to go through, but AI doesn't have all those hindrance. Whatever knowledge it has on C, it also has an equivalent amount of knowledge on assembly. So it really helped us over there to convert a set of assembly functions into pseudocode. I think one thing worth highlighting here is we don't want to actually decompile the binary back into the original source. We just want to know what's happening within the binary. Okay, and this was possible by getting AI to describe in pseudocode what's happening in the assembly code. So what we did over there was we know the region that we were interested in. So we took all the assembly code, starting with the main area, and then all the functions that it calls, and all the place that is referring to that function. So we took all of it together. We were also able to get a type lib out of the binary. So most old legacy COM DLLs, they tend to have this type lib information. So we were able to extract that.
That, by the way, this typelib information played a really big role in the first step, even before the decompilation, because it had all of the interfaces of the middleware functions that were called by the ASP code. So that already was a big component in our inference, in our guesses of what the functionality does, even before we went into the decompilation.
So together with the typelib and the set of assembly functions that we know are relevant to the function that we are investigating, together with the context that we already had before, we were able to get AI to connect all the dots. That was another area that it kind of shined. So it looked at the assembly, it looked at the typelib, it looked at all the previous context that we have, including the stored procedures. And then it gave us a summary of, okay, so this is what is happening in that area of the binary. For example, we learned that when doing this action, there was logic in there that prevents that action from being duplicated. So it was triggered based on a user action. So if the user double clicks, we don't want that to cause issues, right? So the people who wrote that code originally, they had the logic over there to prevent those kind of things from happening. And we also found that there is some calls to mainframe. So we know now that we have a new data source for us to monitor. So all of those things started to come out. But in general, what we noticed is that if we really want to be confident in an area, if we really want to go to the level of detail and make sure that we have not missed out anything, so that's when we bring this big gun and then start looking at the assembly, start looking at all the information that it has gathered so far, and then build a full picture over there.
Yeah, like many or maybe even most things with generative AI, what I'm hearing is that while the AI is certainly it's key to this, it's a very important part of it, this also required a whole lot of expertise. And so, like, I guess kind of as a closing, even though we could keep talking about this for quite a while, for both of you, if someone wanted to do this, they have an application, let's assume they had roughly the same level of access that you had to data and so forth. What kind of team does it take to do this? What's the expertise required to do this kind of thing?
The most tricky part was the part that Chandru just went into in detail, right? And I was really glad that Chandru was on this team because he has experience in the .NET stack and in that whole ecosystem, right? So he could kind of identify that you can't just decompile this with any old C# decompiler, but that it's actually C++ and an older artifact and all of that, right? So Chandru and Thiago, who were working on this together, had like some previous experience in that area, and I think that was really helpful.
I wanted to add on, like, if it was a new person, I think the only context that they need is some background on how the binary was built, and if they're listening to this podcast, they know like what kind of tools to use. So we started from nothing. We did not do this before, and we were able to start making progress within like 3 days of when we started. We ran into all those challenges that I mentioned, and then we solved them quickly. And then we progressed to identifying what's present in the crucial function. I think not more than a week, the whole process it took. So I think as long as they're listening to this podcast and as long as they have a basic background of how their binary was built and what's the context of it, they should be able to ramp up quickly.
I think it's worth noting that we're also talking about a team of pretty senior technologists. So it was easy for a few days for you, but that might not be and that's kind of what I meant is like, you're not going to throw a con grad at this probably, right?
Yeah. I mean, the key skill here is knowing where to look for the data sources. And that means like a certain level of familiarity with this legacy stack, right? So kind of like to know what back in that day, like there's a web server, there's an application server, there's no React single page application, right? And so how can we connect to that web server and get the ASP code? How, like kind of these, and like just to know what you need to look for. I think that's the thing. And that, often when it's a really old stack, you have that experience in people who have maybe worked on that stack in the past, right? Or who know some of these outdated patterns, right? So I think that's the main skill. And then it's about like pulling it all together with prompting and with like the constant risk assessment type of thing that I talked about before, where the risk assessment, again, the probability, a lot of what feeds into that is me knowing about the available data sources in that stack and kind of like a certain confidence in, I think we covered everything that's probably there. We're not missing anything. And if you don't know that stack, you might have a lot of unknown unknowns, right?
I think it's a great illustration that at no part of this process did generative AI do any of the thinking for you. All it did was eliminate busy work, because you had to know what the type-lib business was and how ASP connects to a backend with a DLL and database schemas and all that sort of stuff, and using AI to get rid of busy work. Like Chandru said, if you just given this DLL and decompile the thing, there's no way you would have ever by hand tried to go through and classify it. But because we have the utility of generative AI, which you have to trust but verify at every step, as Birgitta said, you always have to think about, how is this not doing the right thing? But it's a great, for in the hands of a knowledgeable practitioner, it is a very, very powerful force.
Yeah. I mean, basically what we did, there's a buzzword right now, context engineering. And it's more meant in the context of like agentic systems, right? Where you just want to think about like, how do you engineer the context for the agents so that they always have the right information, not too much information and all of that, right? But if you apply the term to this case, like a slightly different type of context engineering, that's what we did, right? Like we put together the data sources and the information that we fed AI to, with a high level of confidence, get like a description of the functionality that we felt like we could trust at a reasonable level for this use case.
So we know the impact of the 20% developer, the top 20% of developers are markedly better than the ones below it. So now my hypothesis is, does the further you get up that stack toward the top 20% developers, does AI actually accelerate their abilities even more? In other words, the more expertise you have, does it actually empower you to become even more productive because you know the places to look for and the things to find and the uses with the generative AI, because you have much more relevant context for the overall problem space?
See, I think yes as well there. If you had asked me this question before we had the models, for me, looking at a lot of assembly files and translating them into pseudocode would have made me give up.
It would have made you quit your job.
So, but now that we have this service which can quickly look at like 16 17 assembly files, all of them hundreds of lines long, assembly being assembly, it can quickly translate it into English for us. That is really a game changer. So at least personally I found it like it enables a lot more things than what was possible before.
Yeah, and this was a specific case, of course. We talked about how it's about an old stack. So naturally, even without Gen AI, if you have experience with that old stack, it helps you be more effective. But I would say, especially in that risk assessment part that I talked about, that I feel like is a lot of what I'm always doing. If it's like when building a prototype, doing agent-assisted coding, doing this type of thing. And there, my experience plays a really big role in like this probability and impact assessment. And, because I have a lot of scars, for example, right? So I have this, it also is really helpful for people with less experience to get, to learn faster, right? But there's definitely a case to be made that when you have that experience, you can use it a lot more responsibly, right?
So we'll add a link to a blog that Birgitta posted about a month ago about some of this. It also goes into testing the feature parity and some other stuff that folks might find interesting. And with that, I want to say, I mean, we can keep talking about this for a very long time, but watch this space. There will be more updates on this and other experiments that the teams are doing. So I want to thank everybody very much for coming. Thank you for your time. Thank our listeners, of course. And we're looking forward to the next episode.
Yep, I think it did, in fact, turn out to be exciting. So Ken was right at the beginning. So thanks so much, Birgitta and Chandira.
Thank you.
Thank you.